Hello, welcome back friends. In this demonstration, this session live is about installing Rocky Linux on UTM running on MacBook with M2 chipset. Quickly, we'll do that installation part. Along with that, we will do machine setup and few services installation on Ubuntu Linux or Ubuntu 22.04 on MacBook with M2 chipset running on UTM-based virtual machines. This is the rockylinux.org website. Download Oracle Linux. Download this Rocky Linux community. Click on the download because we are going to use virtualization. So therefore, native architecture is a architecture, ARM-based architecture. So we'll download the minimum part or DVD. We can download the DVD for Rocky Linux 9. So yes, I want to download this. So once the download is complete, we'll set up this. In the meanwhile, let's go to our UTM where our virtual machines are configured. So this is our UTM where I have configured 3 machines. So first machine is a controller which is already running, and if you want to see the setup, I can show you the setup part of also. So the machine details, if you look at, let me stop the machine and then share the details. Let me stop the machine first, and let me stop this machine as well. I'm stopping all the machines and then I will brief you about the configuration. So the controller machine, if you go to the setup, I'm using the system with AA architecture 64-bit, and this is default CPU. 4 CPU cores have been assigned to this. As far as display and network is concerned, I have given 3 adapters. First adapter is host only, which will be used by internal cloud communication. Second network will be communication, which will be used to connect the instances running in the cloud to connect to the outside world. And third is a NAT based, that is shared network, which will be used to download the instances and packages from internet. Also, I have given 3 machines to these 1 extra disk to the controller to configure Cinder block volume on this machine. So we can start this machine now. This is a controller machine. Let's look at the compute machine. The compute machine is same setting apart from the number of disks. We have 3 extra disks here. One will be used for Cinder block volume and 2 will be used for Swift object storage. So we can start this machine as well. And as far as the storage machine is concerned, similar settings, same 3 networks along with the 2 extra disks which will be used for Swift object storage. As far as CPU and RAM is concerned, I have given 4 GB RAM to this storage node. Controller and compute have 7 GB each, and that's the setting. So we can start all the machines. The first thing I will be doing with the controller and compute machine is, after logging in, I will be setting up the key-based authentication across all the machine as stack user and root user. So best thing is I'll connect using terminal window. I have the IP address. In fact, let me exit from here, and if it is not connected, yeah, perfectly fine. So let's connect to the machine. 10.10.0.11. This is the IP address of my controller machine. I'm using stack user. Password is simple stack. So this is my controller machine. Now if you look at the controller machine, this is the details. Configuration file have the main settings. Configuration directory, config directory have the main settings. Let me show you some setting inside this config. And there's one important file here is OpenStack, where I'm using OpenStack Yoga. So when you are cloning the repository, ensure that you change the release here. You have to make changes at 2 places. One is this Yoga OpenStack release name, and second is one more location is there where you will be using it. So I will show you that also. And this is the network. So first network 10.10.0.0, which is for connecting these machines with each other. Second will be for provider network, which will be used by my cloud. Now another file here is config, not under config rather, let's go to the directory scripts. Inside scripts we have one file here etc host. This file needs to run, and this file will configure the etc host file. We can take a look at the file, sudo cat /etc/hosts, and this setting is done by this script. Remember, this entire setup will be done through shell scripting. Another important script here is a pre-download. This pre-download will download the Sir OS operating system image, but before that, let's check whether we are able to reach Google or not. My internet is working or not. Perfect, the internet is working. So I can use this, run the script pre-download.sh. This script will download Sir OS image, which will be needed by my cloud instances when I'm going to run the instance on the cloud, OpenStack cloud. Next, we'll go to the Ubuntu directory where all my scripts are running available. So inside this we have all the scripts. Like you can see, they are numbered. Script number 1 is initializing the repositories. So let's see the script. 1_apt init, and this script is for initializing and setting up the repositories. Very interesting point here is it will include a lot of files from the config directory like path, OpenStack, localrc, functions. And if you go through the script carefully, here you see the repositories and the release name. So we can use Z and Yoga. You can extend the script to configure for more architecture. This is the same variable which was configured in OpenStack file under config directory. So based on this you can configure. That is interesting thing. Another interesting part here would be this is repository part, so I can simply say okay, that's okay for this part. Now let's run the script to initialize the repositories for OpenStack Yoga. This will set up the repository for OpenStack Yoga. Perfect, done. After the repositories are configured, let's look at the script number 2, which is upgrading it, which is installing OpenStack client and then simply updating the packages. So let's run this script also. This will install OpenStack client and additional packages. Now along with this, as this script is running, we can continue working on the controller node again in the terminal directly to set up the key-based authentication for controller, compute and storage node. Why? Is it mandatory? No, but my scripts will be using it for verification. They will be connecting using key-based authentication using SSH. Providing password for every step will be challenging and difficult. So better is to set up that. So I'm logging into this machine stack. Let me see if I can connect to compute node without password. If yes, then it is set up already. Perfect. So I have configured it for stack user, so I can exit from here. Now let's change to root user sudo su- and try to connect using SSH without password to compute. If yes, this is configured here, but it seems it is not configured because it is asking password, and I have not even configured the password for this user. So I need to stop this. Alright, so what we should to do is we should set up the password here. Passwd for controller node as well as compute node. I'm keeping the password for root user simple. And another important point here is very important to know that for all the nodes, compute, controller and storage, I have made some changes into etc sshd_config. And important settings are, let me set the line number so that I can tell you line number 33 first. In line number 33, you see I have configured permit root login yes. Then line number 38, public authentication yes. And then line number 57, I have uncommented and made the changes to allow a root user to log in using password, because even when you are trying to connect using key based authentication, first time it will ask you for the password. That's what I have done it. So SSH, let's see whether we have SSH key generated here or not. If not, we need to generate. So keys are generated, that's fine, cool. So our controller node, at least password is configured, keys are generated. Repeat the same thing on the compute node. So this is my compute node, stack, and we will see from the compute node as stack user, am I able to connect to the controller node? If yes, that means this is configured. This is configured, perfect. So exit from here, we are back to compute node, switch to root user, generate the key, check the keys are generated or not, .ssh, keys are generated, pass wd to set up the password. I am setting the password for this user, stack, superb. So password is generated. I can pass the key now from compute to controller. So SSH hyphen copy ID. Let's first verify the connectivity. Ping controller. Am I able to connect? Yes. Ping Google. Am I able to connect? Yes. So connectivity is not a problem. And let's run this, pass the SSH key to the controller node as root user. SSH hyphen copy ID controller, yes, password is stack, and it is done. Similar thing I'm going to do from the controller node. SSH hyphen copy ID to compute, password is stack. I kept it simple and it is done. Now same thing I need to repeat on the storage node. Let me connect to the storage node. This is my storage node. Let's log into this user node also, stack, and let's check SSH controller. Am I able to connect? No, not yet, but it's asking for password. No, password is not asked. That means I can connect using SSH controller. Yes, perfect, it is working. So let's verify SSH compute. Yes, connected. So as stack user we are able to do, switch to root user, and we need to verify the same as root user as also. ls.ssh whether keys are available or not. Keys are available. SSH hyphen copy ID controller, okay, let's verify whether we are able to ping controller or not. Ping controller, yes, we are able to ping. Could not resolve hostname controller. Was there a typo? Yes, there was a typo in my while I'm copying controller. Yes, it is done. Key already exists. So SSH controller, yes, we are able to connect to the controller. Try the same thing with storage node, that is compute node. Yes, we are able to connect to compute node as well. So from storage node we are able to connect to compute. Let's set the password for this also. Pass wd stack, and let's verify the same thing /etc. In fact, that is already done. So let's connect from compute, pass the key from compute to the storage node. SSH hyphen copy ID storage. This will pass the key, yes, password is stack. So from the compute node we have passed the key to storage node SSH storage. We are able to connect. Perfect. This is mandatory. Same thing I need to do from the controller node as well. So on the controller node, I will verify SSH hyphen copy ID to storage. Yes, and it's already there. Perfect. SSH storage. Yes, we are able to connect. So key-based authentication for all the nodes from controller to compute and storage is done, and we need to do the same thing, interestingly, for controller as well. So SSH hyphen copy ID to controller to itself, because the same thing will be used to connect as SSH client from controller to controller as well, because script is going to connect to itself. So this is mandatory. Same thing we need to do on the compute node as well. SSH hyphen copy ID compute. Yes, it is done. So SSH compute, let's try. Yes, we are able to connect using itself, using SSH to itself also. So the key-based authentication for all the machine is successfully configured. That's the interesting part. From storage to storage also we can verify. SSH copy ID storage. Yes, so key is already existing. So from storage to storage, from storage to compute, from storage to controller. So all the key-based authentication. In fact, I forgot to check with the same thing for the stack user to itself. So add stack user SSH controller. Am I able to connect? Yes, I am able to connect. So the key is available, configured. So from controller to controller it is working. From compute also I need to verify as stack user. So exit from the root user and SSH hyphen copy ID to compute as stack user. The key is already existing. So SSH compute. Perfect. I'm able to connect to itself as stack user. So our key-based authentication for compute, controller and storage to themselves and to other nodes is working fine. Now let's see the status of the scripts which are running. So perfect. So our script was run successfully. That was script number 2. Let's look at the script number 3, which will install MySQL. Here we have a little problem. The problem is the repository name. I can see the repository is this package is for AMD 64-bit architecture. So this has to be different. Let me check this. And this package has to be for ARM-based architecture is what we need. So let me copy and get the right URL for this. This is interesting because this script is first I created the script for AMD 64 or Intel based architecture. So I need the right this libSSL for ARM based architecture. So I need to change the line. Let us check that. In fact, I can try to paste the URL, command V. I should get the libSSL for ARM based architecture. And the file name, if you see here, is Ubuntu to AMD64.deb. That's what we are looking for. libSSL. This is what we should be looking for. This was I think this was the file. I need to check the right URL. Yeah, and it is okay to go slow. Yeah, this is the file, libSSL. I can search for this name. No, I can search. Yeah, perfect. I can search for this. So let me search with this name, and with the same name, it will be easy for me to search. So command F, paste it. So this is what it is. So we have this AMD 64-bit dev, and what we need is ARM 64-bit. AMD, where is ARM based 64? Let me remove this. Yes, here I should be looking for ARM based architecture. Alright, if it is not available like this, we'll look at for this file with ARM based architecture directly in the Google. Command V. This is what I want, ARM based 64. This one, yeah, this one. This is the file I'm searching for. So download files, proposed, and I need to copy this URL. Copy link address, I'll paste it. That makes sense to me. So I'll just do what? YYP, and instead of this, I'll go to the insert mode, right click and paste. Yes, and delete the line. So here we have this now properly set. wget http launch library libssl ubuntu arm 64 bits. This is main what I was looking for. So I can comment out this line. And here also I need to use the same line. I'm just commenting down the line to make it easy, and I'll download and extract the file. This package is creating problem. If you don't install it, MySQL will not work. MariaDB to be precise. Copy, paste. So this is the file we need to install with the DPK. Rest everything is fine. Rest all will go well. So we downloaded, we extract, and now we can run. This will install MariaDB 3_ MariaDB. So it will download the file. It will install that, and hopefully it should work. Yeah, seems to be working. Cool. Everything will be done by the script. You don't have to worry. Just take care of some URLs and see it is working. MariaDB is working. So our script number 4 is what? Installing RabbitMQ. I can simply run the script to install RabbitMQ. The repository is available on my GitHub account, and you can check that. So I can run this script directly. Install RabbitMQ. If you want to see this URL of the repository, I can take you there. It's GitHub. And here the repository is OpenStack Z. OpenStack Z. This one. This is the repository I'm using. I just cloned the repository. I'm working on it. So this is the repository. So let's continue. Wow, done. So script number 5. Script number 5 is Memcached. So let's run the script to install Memcached. So what we will do in this demonstration is up to Keystone we will be doing it. Remaining part we will do tomorrow at the same time. Be there to watch the complete lecture, complete cloud installation in 2 sessions, 3 sessions. So this is Memcached is already done. Script number 6 is what? Keystone. This is going to install the packages for Keystone. So 6, this will install the packages for Keystone. And the script number 7 will set up the Keystone. Keystone is identity and access management service for OpenStack Cloud. Let me brief you about OpenStack is open source cloud solution used by corporates and clients, and enterprise and for training purpose, testing purpose. It's open source, completely open source. This is my favorite subject for 6, 7 years, 8 years so far. I've been working a lot on it. So after Keystone is configured, let's run the script number 7. We should see the script number 7. Yeah, this is the script number 7, which will create the database, which will set up the service, will make changes into the configuration file, and it will generate the token, create service user, service other users also, and generate the endpoints. So this will set up the Keystone completely on this machine. I was talking about OpenStack. So my favorite cloud is OpenStack, though I'm Oracle certified architect associate, professional associate, and DevOps professional associate. I'm Oracle certified architecture, and I'm Oracle certified instructor also. I'm into Oracle University panel for delivering training for Oracle across the world. Along with that, relational databases, Linux are my favorite subjects. Now this complete the Keystone installation on this, and all machines are ready. Let's look at the download part, which we started, and setup. I was talking about this. This is not yet ready, so this will take time. It appears this is 8 GB size, so this will take time. So we'll complete the demonstration of installation of Rocket 9 on UTM-based MacBook in tomorrow's demonstration. I would like to stop this demonstration today at this point. Hope to see you tomorrow at the same time. Watch complete cloud installation on Ubuntu Linux using MacBook M2 chipset and UTM-based virtualization. Thank you for watching. Take care. Bye.